The next topic is about the initial value problem or initial boundary condition. Like whenever we're talking about initial, so that means the boundary is starting at, if you take a look at time, as time is equal to 0 at the beginning. Or if you're talking about the distance, it's got to start at x equal to 0. And then just go further. So that one is called initial boundary condition. Okay? So, usually in chemical engineering, sometimes you would get the initial problem value in the sense that starting from time equal to 0. But sometimes it could be boundary condition that it can start from somewhere else, not the initial. But that's what this one is going to tell you. It's going to give you the exact equation, exact solution for that condition. Okay. For example, it said that show that 3x is equal to psi x minus cos x is the solution to the initial problem of this differential equation. So that means they just want us to prove that 3x is equal to psi x minus cos x is the solution of this differential equation at this boundary condition. So if we plug these two in there, we should get 0. If we get 0, that means this solution is satisfied with this condition. Okay. The meaning of initial value problem is means the boundary condition at independent variable starting from 0. Okay. So the way to do this is just plug 3x in there. So in order to plug 3x, this one is y, right? Because it's a solution. You've got to do differential of this y term by x 2 times or second derivative of it. Do the first sign, you would get what? Derivative of y by x cos x. The derivative of cos x is minus psi x, minus equal to plus. Do the second derivative of y by x equal to, right? And then you just plug in there, you would get so cos x minus cos x equal to 0, minus psi x plus psi x equal to 0. So we would get 0 equal to 0, which is satisfied. So that means if you have y is equal to psi x minus cos x, it is a solution for d squared by dx squared plus y equal to 0, where we have two boundary conditions, which is achieved at x equal to 0, y is equal to minus 1, and at x equal to 0, the first derivative of y is equal to 1. So, but this one, if you take a look at this y, the coefficient in front of psi is equal to 1, and the coefficient in front of cos is equal to minus 1. But if you change the value to something else, for example, you change to 2 sin x minus 5 cos x, and if you test it with this equation, you would see that you wouldn't get 0. That means this end, so it is satisfied with this boundary only. So if you have different boundaries, for example, if you have like at x equal to 0, y is equal to 5, or at x equal to 0, the first derivative of y is equal to 3. When you plug this initial boundary condition into your solution, you wouldn't get psi x minus cos x. You would get something else. So that solution would fit with the condition that you give it to the problem. So you got to find that solution. Okay. So let's take a look at the next example. For example, if we have 3x is equal to 3, 1, times exponential of minus x and c2 times exponential of 2x. Such that this is the solution for this differential equation. And they're asking you to find C1 and C2. The first one you said you got to prove Cx equal to C1 exponential of minus x plus C2 times exponential of 2x. Prove that this one is the solution of this differential equation and then find C1 and C2. For this boundary. How do you do that? Like I said, if they give you the boundary condition, you should be able to find C1 and C2. But first, you got to prove that this solution, this function is the solution of this differential equation. The way to prove it, you just plug this one into the differential equation. Okay? You got to do first and second derivative of y in order to plug into the differential equation. So the first derivative, what you get? I guess you would get something like this. And then for the second derivative, you would get right? And then you just plug it into the differential equation, you would get two x and then minus 2 equal to 0. We got to check whether it is equal to 0. Now, we get c1 exponential minus x plus 4c1 exponential 2x. Minus minus equal to plus minus 2c1 exponential 2x minus 2c1 minus 2c2. Why I got no c2? Here c2, here c2. Sorry. There you go. Here's c1 minus 2c2. Okay. You have c1 there, here and there. Okay. Combine them together, you would get 2c1 exponential minus x. And then here you got 4c1 and no 4c2. This is c2, right? And we got much. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There. Oh, we don't have this one. Okay, we don't have this one. And this one and this one, you got 2, right? And then this one and this one, you got plus 2c2. And this one minus 2c1 exponential minus x minus 2c2 exponential 2x. Is it equal to 0? I think so. Here, cancel out 0. Here, 0. So, we got 0 equal to 0. That means satisfied, right? So that means y is equal to c1 exponential minus x plus c2 exponential 2x is a solution of this equation. Now, They're asking you to find C1 and C2 by giving you two boundary conditions. In order to find C1 and C2, we got to start from the solution. Our first boundary condition is said that y0 equal to 2. It means that at x equal to 0, y is equal to 2, right? And then you just plug into your solution, because now you know that this is the solution of your differential equation. So you just plug this boundary in, you would get 2 is equal to exponential of 0 is equal to 1, right? That is the first equation. And then for our second boundary, it said that the first derivative of y is at x equal to 0 is equal to minus 3. You got to do differential of this equation. Do the first derivative of this equation by x, right? Which is equal to minus c1 and plus 2c2 exponential of 2x. And then you plug the boundary in, right? Minus 3 is equal to minus c1 plus 2c2. You have two unknown and two equations. Two unknown and two equations. Can you find that two unknown? Yes, you can. You use equation 1 plus equation 2. You would get 3c2 is equal to minus 1. So c2 is equal to minus 1 over 3. Right? Is that correct? You do plus, this is minus 3, you got minus 1 there. You do plus c1 and c1 gone. This one you got 3c2, right? So your c2 is equal to minus 1 over 3. Using equation 1, okay? You know that c1 plus c2 is equal to 2, and you know the value of c2 is equal to minus 1 over 3. So from this, you can get the value of c1, which is equal to 2 plus 1 over 3, which is 7 over 3. So the solution which is satisfied with these two boundary conditions is y equal to 7 over 3 times exponential of minus x minus 1 over 3 times exponential of 2x. And that's the answer.